This lesson deals with the properties of the inductor. You can find these notes in the ECE201 ebook in Chapter 6 starting on page 18. Just like our previous devices of resistance and capacitance, the physical device has an OR ending. And so for inductance, our physical device will be called the inductor. An inductor usually consists of many turns of wire, usually around an iron core. The inductance increases as the number of turns squared, so we get quite an increase as we do each turn. On the next page you can see some sketches of different types of inductors. First one's called an air core. Here it's many turns of wire wrapped around a paper tube. This shape is called a toroid. Looks like a donut with, again, the turns wrapped around in here. This too has some very interesting properties. I use these in switch mode power supplies. Lastly, here's an example of what's called an IF, or intermediate frequency radio coil. And what's inside here are actually two inductors. And we'll talk about the magnetic coupling between these in ECE202. Since the inductor is made with many turns of wire, either wrapped around an air core or a piece of ferrous material, we can model it as an ideal inductance and then take the fact that that wire has some resistance, as we'd illustrated in some of the supplemental problems in Chapter 2. This resistance we call the effective series resistance. If you measure it at DC, then the inductance looks like a short circuit, and all you see is just the value of this resistance. This is a pretty good model for low frequencies in DC. We'll talk about more complex models in later courses when the frequency increases and our need to increase the modeling needs to be addressed. And these are some of the properties of the physical device called the inductor.